When we consider the load current delay that is manifested by the ReGenX generator coil and how that contributes to the regenerative acceleration phenomenon, we need to look at the sine wave, the load current sine wave of a conventional coil. Here, this is the top half of the load current sine wave of a conventional coil, and we have the top half of the sine wave of the ReGenX coil. Now, in the load current delay video and the test data, we were using a purely resistive load on the output of our conventional coil, and the same purely resistive load on the output of the ReGenX coil. That means that the power factor of the load is 1, and that means that the load current and the induced voltage in the coil are in phase. So the load current sine wave and the voltage sine wave are in phase. So what that means is that the position of the rotor magnet, if we have a north pole rotor magnet that is approaching the coil's core, as the rotor magnet approaches the coil, the voltage is built up inside the coil, and the current, which is in phase, is also increasing. As the current increases, the induced magnetic field in the coil, which has the same polarity as the approaching rotor magnet, its induced magnetic field is also increasing. So as the rotor magnet gets closer to the coil, the induced magnetic field is increasing, and the coil creates increasing amounts of counter-electromotive torque, or increasing amounts of regenerative braking, however you want to look at it. Now, when the rotor magnet moves past the coil, past top dead center, past the current crust, now the current flowing in the coil changes direction. The induced magnetic field from the coil turns into a south pole, and the coil resists the rotor magnet's departure away from the coil. So the regenerative braking aspect, the generator armature reaction, the counter-electromotive torque produced in a conventional coil is always resisting the rotor magnet's approach and always resisting the rotor magnet's departure. The ReGenX coil's load current delay is important because what it does is it shifts the load current in the time domain such that when the rotor magnet is approaching the coil, the load current is delayed. So the counter-electromotive torque, or regenerative braking component, only occurs up to top dead center. Now we can see that once the rotor magnet starts to move away, the ReGenX coil is still inducing a north pole magnetic field around the coil, and this north pole, this induced north pole magnetic field assists the North Pole rotor magnet's departure away from the coil. And it also assists the South Pole rotor magnet that's now coming into position. So the ReGenX coil's load current delay resists the rotor magnet's approach until the rotor magnet is top dead center to the coil, and then after that it's assisting and accelerating its departure from the coil. This is where the ReGenX coil derives its regenerative acceleration, and basically this is how the ReGenX coil operates. And as we saw in the video demonstration number 1, the load current delay is responsible for the ReGenX generator action.